Hello, and welcome to our demonstration of ParlAI Vote, an interactive system for exploring European Parliament debates and votes. Our platform connects debate topics, speeches, and roll call outcomes with demographic attributes such as gender, age, country, and political group. Using large language models, ParlAI Vote lets users test gender prediction and vote prediction, analyze fairness, and visualize systematic biases in model behavior. Turning to our motivation, large language models are increasingly used in politics, raising concerns about reliability, fairness, and misuse. Recent examples highlight both opportunities and risks. Reuters reported that an AI-simulated U.S. Federal Reserve meeting revealed political pressure on AI. AP News found that chatbots spread misleading election information in Spanish, raising risks for Latino voters. At the same time, even basic access to European Parliament data is challenging. Roll call vote records are encoded with symbols, difficult to interpret without context, and debate transcripts are stored separately from the votes, making it hard to link arguments with actual decisions. Our system tackles this problem directly, unifying debates, votes, and demographics into one accessible platform. Our system is built around 3 layers. First, dataset visualization, bringing together 969 roll call votes with multilingual debates and demographic information. Second, the vote prediction module, allowing users to compare outcomes across multiple large language models and explore counterfactual scenarios. And third, the gender prediction module, highlighting systematic bias in how political speeches are classified. Together, this design makes a complex benchmark explorable for both researchers and the public. Let's walk through the system. From the homepage, we can search by keyword or sort by date to quickly find a debate. On the vote page, the first panel displays the metadata, including the debate topic, date, a link to the full debate text, and the number of participants. Next, we see a breakdown of how members voted across groups and demographics, giving a clear picture of political alignment. The next section is the prediction panel, where large language models simulate votes. Here, users can search for MEPs by name or filter results by gender, political group, or country. Within this panel, users can establish a baseline by viewing the MEP's actual vote, which serves as the ground truth for evaluating prediction accuracy and bias. For non-English transcripts, one click translates the text into English for effortless understanding. Compare models by running different language models side by side, enabling direct comparison of performance and potential biases. Test for bias with counterfactual analysis. By modifying demographic variables, users can isolate the influence of specific factors and uncover systematic bias. Inspect reasoning by examining the rationale behind each prediction. This addresses the black box problem and enhances transparency. Gender prediction module complements vote prediction by probing linguistic stereotypes. Users can predict gender from speech text, add demographic context, and observe how outcomes shift. This makes abstract bias tangible, revealing patterns such as higher misclassification rates for female members. Highlighted text reveals where the model may have relied on biased or stereotypical cues, enabling users to spot and reduce potential fairness concerns. Together, these features integrate political data with AI analysis in a single interactive interface, allowing users to explore both political alignment and systematic bias with clarity and depth. Now, let's turn to our key findings and insights. In gender bias and gender prediction, open-weight models often default to male. For example, Llama 3.2 misclassifies over 70% of female speakers, while proprietary models like GPT-4o achieve more balanced results. In gender bias in vote prediction, accuracy drops when all MEPs are labeled female and improves in all male settings. Proprietary models remain far more consistent across conditions. In political bias and vote prediction, models perform best on centrist groups such as Renew and SD, but performance is uneven at the extremes. Far-right groups are predicted more accurately than far-left ones, revealing an ideological asymmetry. Finally, in our analysis of voting misclassifications, we see 3 common errors: over-reliance on keywords, confusing sentiment with stance, and failure to detect sarcasm or irony. In summary, ParlAI Vote is the first AI-powered system that unifies debates, roll call votes, and demographics into one interactive platform. By making model predictions transparent and biases explorable, it lowers the barrier for reproducible research and public engagement. We invite you to try our demo and join us in critically assessing the role of AI in political decision-making. Thank you.